So Bernoulli's principle is an idea that now that we know flow rate, we can understand how the pressure applies to this idea of flow rate. If we take position A and position B, we know that the water flowing at position A is going to have some velocity, whereas position B is going to have a greater velocity. And that's due to the fact that the area times the velocity, the product of those two must remain constant. So based on pressure then, what does that tell us about the pressure of the fluid through A versus the pressure of the fluid through B? Now, if we think about a water particle that is moving from A to B, right in this location, it's going from a lower velocity up to a higher velocity. So what that tells us is that during this time here, there is some acceleration. It's changing its velocity. So there's an acceleration that's causing that change in velocity. Now, if we know there's an acceleration, that also means that there is a net force on my water particle. And my net force always points in the same direction as my acceleration. So my net force must also point forward. So how can we use this to understand what the pressure in a fluid is doing? Which one has a higher pressure, A versus B? And what does that mean? And how can we, which one has a higher pressure, A versus B? And how can we use that? And how can we use the idea of their velocities to indicate and tell us which one has a higher pressure? So if we look at this, because our net force is to the right, we have to think about all the water behind this has some pressure that's pushing it forward. So that's the pressure due to A. And all the water in front of this water particle is pushing it backwards. It's trying to resist it moving. So that's the pressure at B. So we have some pressure at A, and we have a pressure at B. Now, pressure, remember, is force over area. And so we can think about A, water pushing the water forward, and B, water pushing this backwards. And so if my net force is to the right, that tells me that the force pushing it forward, the force due to the water at A, must be greater than the force due to the water at B, because those two have to balance, or excuse me, those two are not going to balance out, and instead they're going to give me a net force at this position pointing towards B. So if that is true, the area that they're acting on, this entire area, is the same for both A and B. So if their forces are different, but their area is the same, then their pressures must also be different. And what we can see is with this, if my net force is forward, the force at A has to be bigger than the force at B, and so that tells me that the pressure at A must be greater than the pressure at B. So what this can tell us about the pressure in a fluid which is flowing is that the greater the velocity, means the lower that the pressure is going to be. As I speed up, the pressure goes down. As I slow down, my pressure increases. And so it's an inverse relationship between the idea of the velocity of the water and the pressure which that water exhibits. Think about an idea that if we have a hose with water flowing through it, right? And all of a sudden we step on the hose right here, right? We step on it or we put a kink in it. What's gonna happen is the pressure is gonna start building up here. And this hose, might expand in size. Our water's not flowing fast. It's actually barely flowing at all. And that's where we get this increase of pressure because our velocity of the water is decreasing. Whereas you might have a little bit of water that squirts through, and that's at a very low pressure. But it's the idea of the slowing down of that water that increases the pressure within the system.